All right, we're going to talk about numbers. But I promise, this is not going to be your high school math class. Instead, we're going to peel back the curtain and look at the secret story. The hidden lives of the numbers you use every single day.
I mean, really think about it. You use them to check the time, you use them to cook, to see how fast you're going. But these numbers, they have these hidden depths, a whole family tree that stretches back for thousands of years. So let's go meet the ancestors.
Every great story has a beginning, right? And for numbers, that story starts with the most basic human need there is, the need to count. To figure out how many sheep you've got or how many days till the next harvest. And that brings us to these guys, the natural numbers. These are the very first numbers any of us learn. 1, 2, 3. They just feel simple, intuitive, almost, natural. They are the absolute bedrock of everything that comes next. For a long, long time, that was pretty much it. But then, a concept so powerful it changed everything came along. The idea of nothing. Zero. Now, this wasn't just adding another number. This was a total mind-bending leap that gave us a placeholder and a starting point for a whole new world of math. So, we can count things, and we've got a symbol for nothing? We're good, right? Well, what happens when you owe someone $5 or when you need to split a pizza between 3 people? Simple counting just doesn't cut it anymore. Humanity needed new kinds of numbers for new kinds of problems. And here is the brilliant solution. Integers. All of a sudden, our number line wasn't just a one-way street anymore. It stretched out infinitely in both directions. For every positive number, we suddenly had its opposite. This let us talk about things like debt, or ocean depth, or freezing temperatures. But what about all those little spaces between the whole numbers? For that, we invented rational numbers. These are the numbers of fairness and precision. A half, 3/4, 5/8 of anything. Basically, any number you can write down as a simple fraction, it fits into this massive, super useful family. Now, you'd think we'd have it all covered, right? We've got positives, negatives, and every possible fraction in between. Our number line should be totally packed. But, and this is what's so wild, it's not. It's actually full of these tiny invisible holes, gaps that are filled with a completely different, kind of weird kind of number. Meet the irrationals. These are the rebels of the number world. They just refuse to be written down as a nice, neat fraction. Their decimals just march on forever, never ending, and, get this, never even repeating a pattern. Think of pi or the square root of 2. They're just endless and totally wild.
And this slide just lays out the core difference perfectly. Rational numbers are predictable. Their decimals either stop cleanly, like 1/2 is just 0.5, or they fall into a nice repeating loop, like 1/3. Irrationals, on the other hand, are just pure chaos, an infinite, totally unique string of digits that never repeats. So what happens when you put them together? When you take all the neat, tidy, rational numbers and you pour in all the wild, infinite, irrational numbers, you finally get the whole shebang, the real numbers. Now, at last, our number line is truly complete. No gaps left. Okay, so we've mapped out all the major families. But now, let's zoom in a little bit, because inside these families, numbers have their own unique personalities and little cliques. Seriously. Some are builders, some are loners, and some are just, perfect. First up, we gotta talk about the superstars, prime numbers. We're talking 2, 3, 5, 7, 11. These guys are the indivisible atoms of the number world. You just can't break them down any further. They are the fundamental building blocks from which all other numbers are made. And believe it or not, their secrets are what keep our entire digital world secure. And if primes are the atoms, then the composite numbers are all the molecules. Any whole number that isn't a prime is a composite, which just means it's composed of prime numbers all multiplied together. So 4 is just 2 times 2. 6 is 2 times 3. They're all just built from primes. Then you get these really rare, beautiful little things. Perfect numbers. A number is perfect if you add up all the numbers it can be divided by, not including itself, and you get the number right back. So take 6. Its divisors are 1, 2, and 3. And what's 1 plus 2 plus 3? It's 6. It's this perfect, elegant balance. The next one isn't until 28. Okay, so this all leads to a really profound question. We said primes are the building blocks, but is there a blueprint? Is there some kind of unique code that actually defines every single number?
Well, the answer is a huge yes. So how do we find this code? Well, let's just take a number, say 60. As you can see here, the whole process is just breaking it down step by step using only prime numbers. We just keep dividing and dividing until we can't go any further, and what we're left with are the fundamental pieces of 60. And here is the absolutely crucial part. This isn't just one way to break down 60, it is the only way. That specific combination, 2 2s, 1 3, and 1 5, is the unique prime fingerprint for the number 60. It's literally like its DNA. No other number in the entire universe has that exact same code. And this incredible fact isn't just some neat little trick. It's a foundational law of mathematics. It's so important that they call it the fundamental theorem of arithmetic. It says every single number greater than 1 is either a prime itself, or it can be built by multiplying primes together in exactly one way. And this leaves us with a really fascinating final thought. If every number has a unique, secret code, how hard is it to crack? For a small number like 60, it's easy. But for a number that's hundreds of digits long, it becomes practically impossible. And that exact difficulty, that's the lock that's protecting your credit card numbers online every single day. The secret lives of numbers, it turns out, are the secret to our own.